explore outlier detection and treatment. And first we have to install the necessary libraries. Then we install as well the dataset that we work with. This is the HDI clean dataset, which is a already cleaned version of the Human Development Index downloaded from Kaggle. Here you can see 11 different columns that indicate the Human Development Index, the country and region, and different sub-indices. This is the tail of the dataset. Since there are no missing values, as you could see here, I don't have to think about the treatment of null values. And before applying machine learning algorithms, I would have to encode the columns of type object, which are country, region, and human development. However, to be able to interpret the outliers and assign them to a country, I don't do this now. But I'm aware that I should do this before actually working with the data and making prediction and applying algorithms. Now we visualize the distribution of the data, more specifically of the column gross national income per capita. You can see that it's highly skewed, and most of the data is towards the left side of the distribution. Now we detect outliers. Sorry. We start with the Z-score method. This method defines a lower and an upper bound below or above which the data points can be classified as outliers. It assumes a normal distribution, which is not given in this case, as you can see here. So this method is applied for training purposes only, but we cannot really trust the outcomes. The formula for the bounds are, for the upper bound, mean plus 3 times standard deviation, and for the lower bound, mean minus 3 times standard deviation. In this case, the lower bound is minus 276 and the upper bound is 342. In theory, we could ignore the lower bound from now on because it doesn't really make sense to have a negative GNI. But for comprehensiveness, I will just include it now. And yeah, I guess it's good for training purposes as well to just include it. It doesn't harm. So now I kind of screen or filter the data column GNI according to the upper and lower bound. So it will show any values that are above the upper bound and any values that are below the upper bound due to the indication of the OR parameter. So you can see this applies to 3 countries, Burundi, Central African Republic, and South Sudan, which have pretty high GNI values. Let's move on to the IQR method, the interquantile method. I don't know what the R stands for. I will look it up. This method is sensitive to the underlying distribution, and it doesn't assume normal distribution per se. So in this case, it is applicable since we have skewed data. The formula for the bounds are, for the upper bound, the 75th quantile plus 1.5 times the standard deviation, and for the lower bound, the 25th percent quantile minus 1.5 times standard deviation. So I define this now. And the bounds are, in this case, minus 34 and 69. Again, we could theoretically ignore the lower bound, but I will not do this in this case. And again, I will filter for these conditions. So for any values that are above the upper bound and values that are below the lower bound. And I will display the columns country and GNI. So here you can see that since the threshold, the upper bound is lower than in the Z-score method, there are more more rows that are displayed or that fulfill this condition. So looking at this data, it would actually probably make sense to only treat the developing countries. So in this case, Burundi, Central African Republic, and South Sudan as the outlier. These are the three biggest outliers, and they collectively have like a big jump to the fourth smallest outlier, which is Liechtenstein. So it's kind of a large jump from 146 to 732. And probably these three values, this is an actual error from the data input. And these ones are just above average, or like according to our methods, these are outliers, but this is probably actually an error. So if I would work with this data in real life, I would kind of think about what to do about this. But since this exercise is about exploring this outlier detection method, I would just take it as it is and treat all of these 8 rows as outliers. Also, we can detect outliers by a visual method, which is the box plot, which kind of relies on the IQR method. It's just a visualization of it. So here you can see that there are several outliers out of the 75% bound. Now we have to think about how to treat these outliers. So there's a large range of outlier treatment methods. And apart from the ones that I will display here, there are methods like winsorization and binning. The former makes outliers less influential by putting a restriction on the sample and replacing the outliers with less extreme values that can be defined through different methods. For example, the 5% most extreme values are replaced with a value at the 5% fifth and 95th percentile, and this would preserve the general distribution of the original data. And when binning, you can categorize numerical variables by making groups, and for example, outliers would be values contained in the first and last bin. But I will not further elaborate on these methods here. Instead, I will focus on trimming, capping, and imputing. So trimming refers to deleting outliers, and here I will do this based on the z-score that we calculated before. So first I will make a copy of the data set. And then I will simply replace the I will simply replace the data that is an out, or no, I will simply, no, I will only keep the data that is not an outlier. So I kind of reverse the conditions formulated in the z-score. So here, anything that is below the upper bound and anything that is above the upper bound. And I use the AND connector here. So here you can see we only have 188 rows left, which makes sense because previously we had 191 rows and 3 rows were outliers, so they were deleted now. Let's move on to capping. Here we replace outliers with the value of the upper and lower bound. And I do this based on the values calculated by the IQR method. So again, I will make a copy. Yeah, just make sure that it copied correctly. And now I will apply the np-where function. So this basically checks for the condition that if the the data points in the column GNI are above the upper bound or below the upper bound. So here in the first where statement, it checks for if it's above the upper bound. If it is above the upper bound, then the value is just replaced by the upper bound. And if it's not, then moves on to the second where statement. Then it filters again if the value is below the lower bound. If it is replaced by the lower bound. And if it's not, so if it's not an outlier basically, then the value is just kept as it is. So it's just, yeah, which is defined here. And just to check that it worked, I will look for one of the outliers. 190 was, in this case, South Sudan, and check if it replaced this high value with the upper bound. So I do this now. And here you can see that it actually is a new value here at 69, which was the upper bound. So it worked. And lastly, we will look at imputation, where you can replace outliers with, for example, median or mean. I will use median because mean is sensitive to outliers themselves, so it doesn't make too much sense. And again, it's based on the IQR method. I'll make a copy. And then I create a new column based on the gross national income column, which is called out. And it's a Boolean column that defines, or that says if the condition is fulfilled or not. So you will see in a second what I refer to. So here you can see that 183 data points or rows do not fulfill the condition, so are not outliers, and 8 are actually outliers, which is in line with what we've detected above. And then I create another column called imputed with an MP statement. So here I filter for all values in the out column, in the out column, which are true, so which are an outlier. And then I replace these values by the median of our data points of the GNI. And if it's not true, they are just kept as they are. Just to make sure that it worked, I will show the median, which is 12.6, and the upper bound, which is 69. So as you can see, the 8 detected outliers plus the median, which is Suriname, are replaced by, here in the imputed column, are replaced by the median value. Yeah, here I just wanted to show that the median actually is Suriname. And now we can just make the data set a bit nicer by dropping the columns GNI and out, since we don't need them anymore. And then we rename the column imputed to GNI imputed. And that's it.